The Beauty of Coding Snowflakes in TurtleStitch by Elaine Wolfe. Please note, all of the links provided in this slideshow will be in the YouTube description. Snowflakes are a thing of beauty and wonder. Our ideas for TurtleStitch come from the nature around us. Imagine walking through a forest on a cold winter day with snowflakes falling from the sky. There are hundreds of millions of them falling gently to the ground. You reach out and touch one with your gloved hand, and there lies a perfect snowflake in all of its wonder. But wait, the next snowflake looks just as beautiful and unique as the last. How can this be? How can each snowflake be more beautiful and different than the last? Looking closely at the structure of a snowflake, you will see that each snowflake almost always has 6 points. Occasionally, there's an anomaly, and it is only 3 points. But why is it true that there are only just 6 points in a snowflake, you may ask? The answer is in the structure of the water molecule. Water is made up of 2 hydrogen atoms and 1 oxygen atom, H2O. Each snowflake is made up of billions of water molecules, and at the core are water molecules that are holding hands. These water molecules at the center create the 6-point structure or hexagonal shape. Atmospheric conditions such as temperature and humidity change the structure of the forming snowflake, but the core shape always remains the same. An interesting book about snowflakes is Snowflake Bentley by Jacqueline Briggs Martin. Here's a YouTube video of a reading of this book. The book depicts the true story of a child named Wilson Bentley who was fascinated with snowflakes. Bentley's enthusiasm was misunderstood at the time, and people used to make fun of him. His patience and perseverance of looking at snowflakes under a microscope was rewarded when his parents gifted him with a camera to document the uniqueness of the snowflake shapes. In 1885, he photographed the first snowflake in Jericho, Vermont. He went on to photograph and publish a book about snowflakes. Wilson Bentley, a self-taught scientist, was the first person to claim that no 2 snowflakes are alike. Here's a link to a lesson plan from the Smithsonian if you'd like to learn more about snowflakes and Snowflake Bentley. The TurtleStitch snowflake. The mission here is to create snowflakes using TurtleStitch. Start by making a 6-point structure. A spoke is just a straight line. There are 2 different ways to draw a spoke. You can use either method. Both work the same. Notice that in both examples, the turtle ends up facing the same direction. In the example on the top, you see that the turtle is moving 100 steps and then moving minus 100 steps. In the second example, he's moving 100 steps, turning 180 degrees, moving 100 steps, and then turning again another 180 degrees. Coding the spokes of a snowflake. Since a snowflake has 6 sides, the next step is to place 6 spokes evenly around a circle. A full circle is 360 degrees, so each spoke needs to be separated by 60 degrees. 360 divided by 6. In the code, you will see that we use the same move and turn commands from the previous slide, then added a 60-degree turn to point the turtle in the right direction for the next spoke. Wrapping this sequence in a repeat 6 block allows the turtle to draw all 6 spokes, completing the snowflake shape. Adding an endpoint to the snowflake spoke. A square was added as an endpoint to this snowflake on the left. The first turn is only 45 degrees to set the square into position. The next 4 turns are 90 degrees to complete the square. There's a 45-degree turn followed by moving the turtle back 100 steps to return it to the center of the snowflake. Now we turn the turtle 60 degrees to create the next spoke. Repeat this code 6 times to complete a snowflake with square endpoints. A diamond was added as an endpoint to the snowflake on the right. The first turn is only 30 degrees to set the diamond into position. The next 4 turns are 60, 120, 60, and 120 degrees to complete the diamond. There's a 30-degree turn followed by moving the turtle back 100 steps to return it to the center of the snowflake. Now we turn the turtle 60 degrees to create the next spoke. Repeat this code 6 times to make a snowflake with diamond endpoints. Adding circle endpoints to this snowflake spoke. A circle was added as an endpoint to this snowflake. The first turn right 90 degrees will align the turtle in the correct position for the arc left block. A circle of radius 15 is then drawn. There's a 90-degree turn followed by moving the turtle back 100 steps to return it to the center of the snowflake. Now we turn the turtle 60 degrees to create the next spoke. Repeat this code 6 times to complete a snowflake with circle endpoints. Please go to the link that's provided on this page so you can see how a snowflake is made and how a snowflake is made with the different types of endpoints. Here are some snowflakes that I created in TurtleStitch. In each snowflake, a different feature was added with a turn or a move. As in nature, snowflakes can become very complex structures. Please stop the video and go to the link that I've provided here to see how these snowflakes were made. Making a snowflake with branches. When the code to the left is run 6 times, 2 error messages are produced. The 2 error messages are shown on the right. The first error message is a clamping message. It's an indication that you haven't chosen an embroidery stitch. Check out the program to see the code in action. Please stop the video and go and see it. Making a snowflake with branches. An embroidery stitch has been added to the code to the left and the clamping warning is no longer present. The density warning means that there are too many stitches on top of one another. A fix for this problem was moving 10 steps away from the center. The first move of 10 steps is to move away from the center of the snowflake to eliminate density warnings. Looking at the code, the interior loop of repeat 10 means there are 10 branches on each side at a 60-degree angle to the spoke in 50 steps. I turned 180 degrees minus the angle measure to get back to the center of the spoke. I repeated the 60-degree angle move on the other side of the spoke for each branch and returned back to the center of the spoke. I moved the turtle 50 steps to the next branch position and repeated the move back and forth across the spoke. Once the 10 branches were made, the turtle was moved back to the center of the snowflake 0, 0, which is the origin. This spoke code was repeated 6 times to complete the snowflake. The overlying branches in the center of the snowflake produce the interesting pattern in the center of the snowflake. Making a generalized snowflake with branches. This program is exactly the same as the previous program, except the numerical values were replaced with variable names. The variable names were given values in the beginning of the program. This type of coding makes it easy to change values of different variables without having to change the logic of the code. If you look at the code to the left, you see that the variables are branches, branch angle, branch length, and branch steps. Please stop the video and go and see how this code was made. Making generalized snowflake with randomized branches. Another iteration of the Snowflake program. This program is exactly the same as the previous program, except the variable names were given a range of values with the pick random block. This generates random numbers between the numbers that are specified. Each time the program is run, a different snowflake is created with different number of branches, with different angles at which the pair of branches intersect the main spoke, different branch lengths, and different spacing between the branches. If you like a certain snowflake design, write down the randomized number that created the snowflake to recreate it. Remove the pick random block and replace it with the values that you like. The values are shown in the stage area. And if you look at the picture of the snowflake, you will see that there's an orange block. And in that block, you will see a number, and that is the random number that was used in the program. Stop the video now and go to the link to see how this works. making 9 generalized snowflakes with randomized branches. Continuing the quest to make beautiful snowflakes, this program generates 9 random snowflakes because there are 2 nested for loops, which creates the rows and columns of snowflakes. The 4x value represents the rows moving left to right, and the 4y value represents the columns moving vertically up the grid. The outer loop y starts with its first value. Then the inner loop x runs completely, processing all of its set of instructions for that particular value of the outer loop. Once the inner loop finishes, the outer loop moves to its next value. This process repeats until the outer loop has gone through all of its values. Again, stop the video and try out the program. Embroidering the snowflake design. A snowflake ornament was made by coating a satin stitch around the snowflake design and adding a circle as a hanger. Craft felt was used for the design. Once embroidered, the design was cut about 1/8 inch from the satin stitch. It is not recommended to cut any closer to the satin stitch, as a slip of the scissors might cut the satin stitch threads. A bow and a thread hanger were sewn on to complete the snowflake ornament. I hope you enjoyed exploring the mathematical beauty of coding snowflakes in TurtleStitch. Please visit my blogs, papercraftetc.blogspot.com and turtlestitch.blogspot.com. There you will find more fun projects featuring math-based designs. Thank you for watching.